Hi everyone, my name is Anoop Damani. I'm part of VPC product management team. Um, Welcome to the webinar. The goal of this webinar is to give you in-depth insight into a new feature that we launched at AWS Reinforce event during the keynote, which is VPC traffic mirroring. VPC traffic mirroring is a feature that allows you to monitor traffic, your VPC traffic, through any monitoring tools of your choice for use cases like content inspection, threat detection, and so on and so forth. So before we get into specifics of this feature, I want to make sure that our audience is aware about some of the foundational aspects of VPC, specifically how networking in VPC works, and up until today, before traffic mirroring, how customers have been using flow logs to monitor their traffic, and how flow logs essentially complements with traffic mirroring. So let's get started. As I mentioned, VPC and the networking aspects are pretty foundational for anything that you want to do in your AWS environment. So for example, you might have an Amazon EC2 instance, and you might have a relational database service called Amazon RDS, or MapReduce service, which is Amazon EMR, or you might have any other instance running any other service. For these instances or services to talk to each other, you have to set up your networking right. And once these services are talking to each other, it is essential to understand how you can monitor your traffic, specifically on your workloads which are running some critical applications. So let's take a closer look at the VPC, some of the foundational elements. So the key things here, obviously, is Amazon EC2 instance where you're running your application, and VPC where your EC2 instance are running. So to start off with, you have a region, and then you have a VPC in that region. You allocate a CIDR to that VPC, and then obviously the CIDR can be IPv4 or IPv6. Then you have availability zones within VPC. And you have subnet that are bound to availability zone. The subnet could be public subnets or private subnet. Now you can choose to run EC2 instance within this subnet. You can give an IP address to this instances, and now you have an internet that you want these subnets to talk to. You also have services which are global services which are available or reachable through internet, like Amazon S3, DynamoDB. There's a clear demarcation. These services are accessible from your VPC over internet, and obviously you need a connectivity to these services through some kind of a connectivity model. So let's take a look at how the first step to make any connectivity work is to establish or configure your route table correctly. Route tables are essentially bound to a subnet, and they come with a default local route, and you have essentially route table in every subnet. You have your, for example, you have these services in S3. So you have global services which are reachable over internet. In order for you to have connectivity to these services through internet, you need something called internet gateway. You need to configure your routes so that your internet gateway can actually take this traffic from your subnet. And once you have your route table configured correctly, you can point your traffic, which is bound for internet, through IGW, which is your internet gateway. Now, if you have private subnet, you can actually connect to outside world through NAT instance. Your NAT instance will actually convert your private IP to public IP and then send the traffic over IGW to the internet. You can also use, hopefully, NAT gateway, which is a highly scalable NAT service that we offer, where you don't have to worry about the high availability or scalability of an instance, and you can use NAT gateway for your external connectivity. We have things like VPC endpoint that allow you to connect to your these services like S3 or VPC endpoint so that your traffic remains in AWS backbone. We have a gateway called virtual private gateway, which allows you to connect to on-premises network through VPN or through Direct Connect. And obviously, for all of these connectivity model, you need to configure your route table. Then you have peering, where you can peer one VPC to another, and with the right route table configuration, you can use peering connection to reach to another workload deployed in another VPC. Now you can also connect multiple VPCs through Transit Gateway. Now Transit Gateway is essentially a product that you can use to connect up to 5,000 VPCs in your AWS environment. You can also consolidate your connection from on-premise through Transit Gateway. We have things like AWS Private Link that allows you to connect to a service provider application or a SaaS application through AWS Backbone. And all of this traffic that's coming in and out of your VPC environment can be sent to CloudWatch or S3 using flow logs. We'll cover flow logs in a detail in a bit. And then you have Global Accelerator at the top. So this is just a quick snapshot of what you can do with your AWS environment. And the key thing here is that how do you keep an eye on the traffic coming in and out of your network. So let's get started with flow log first. I want to make sure that you're aware about what you can do with flow logs and how your flow logs look like. So a flow log essentially allows you to actually create sources. You can have 3 sources. Your source can be as granular as an EC2 instance, or it could be a subnet or a VPC. And flow log can then send this traffic, the metadata of the traffic, to CloudWatch or S3. How does flow log look like? So let's take a look at the content of flow log. Flow log has a version number. Currently the version number is 2. It has the account ID where the flow log is sourced from. It has interface ID of the traffic where of an EC2 instance where traffic is coming in and out. Then it has the source address and the destination address of the packet leaving that interface ID. You obviously have source port and destination port as well. You have a INA protocol number. Then you have the packets in the byte count and the start and end of the timestamp, and then the action, whether it's accepted or a rejected traffic, and then you have the status of this of the traffic or log status. So let's look at how VPC flow logs are a building block to analyzing the traffic. You can use flow logs to capture IP traffic, or specifically the metadata of the traffic in your VPC, that allows you to monitor your traffic at a high level so that you can look for suspicious traffic patterns coming in and out of your network with the metadata that we just looked at. Or you could actually use it for troubleshooting and diagnostic purposes in order to understand how your security groups are acting for a traffic, or a network ACLs are acting for a traffic. Let's take a look at a simple example of how the VPC flow logs look like. Let's say that you have traffic going between instance A, which is deployed in a subnet, and instance B, which is deployed in another subnet within the VPC. And you have security group that is referencing attached to these ENIs, which are referencing each other, which means that both A and B can talk to each other. And if you are looking at the flow logs of the traffic going between instance A and B, you could essentially enable flow logs and send it to S3 and CloudWatch. And obviously you need to have connectivity to S3 or CloudWatch. And you would see a log very similar to this, where you have version number all the way till the action that we just covered for traffic which is going from instance A and B. Keep an eye on that action where you can see whether it's accept or reject. Accept means that traffic is allowed by the security group, and reject means the traffic was rejected by the security group on the instance. Similarly, you have a instance B flow log where you have a traffic in the reverse direction captured in the flow log. Now, let's take an example where you have instance A and B, very similar scenario, but now you have a security group such that only A can talk to B, but B can't talk to A. In such scenario, your flow logs will be very similar to what we saw. The only difference is that the traffic flow from instance A and B would look like absolutely the way it looked like in this previous slide. But from B to A, your action will be instead of accept a reject, because that's how you configured your security group. So, and as I mentioned, you can have multiple destinations on VPC for VPC flow log. It could be Amazon CloudWatch. It could be Amazon S3. You could also use Amazon Athena. There are multiple use cases for Amazon Athena. You could go to this URL where we have captured some of the use cases where customers are using Amazon Athena for flow logs. And our customers have actually developed a lot of cool stuff on top of flow logs. So we have a breakout session from last reInvent where customers, specifically Netflix, has done a bunch of cool stuff with flow logs. So I highly encourage you to go and watch this reInvent recorded video on YouTube. And we also have a case study with Netflix on how the flow logs are being used with Amazon Kinesis by Netflix. Now, this was about VPC. We covered some of the foundational aspect of VPC, specifically networking and flow logs. Now, let's get into the traffic mirroring feature that we just launched in AWS Reinforce on June 25th. So, how does traffic mirroring work? At a very high level, it works very similar to how traffic travels between the two medium. You have an incident ray, and then you have a part of the incident ray being reflected, and part of that is refracted. And very similar to that, when you have packets traveling on a network interface, you could specify what part of the traffic can be mirrored so that you can send it to a monitoring appliance for analysis purposes. So at its core, how does traffic mirroring work? Let's take a look. So you have an EC2 instance in your VPC, and you have traffic coming from an internet gateway to this instance, and you have a green packet coming in, blue packets going out. Now, let's say that you decide to monitor this instance. This happens to be one of the critical instance or a workload running an important application in your network. The first thing you do is you enable or you create a monitoring instance where you want to receive the mirror traffic. And then you go and create a mirror session. By default, there are no mirror session in your VPC, so you have to create one. Once you create that, traffic mirroring is enabled on a specific source. So in this case, we have enabled traffic mirroring on the ENI of the EC2 instance that we want to monitor. And once it's done, you can specify the monitoring instance as your target, and all your traffic which is coming in and out of the ENI is now mirrored to this monitoring instance. Now, what kind of monitoring instance you can use? You can use essentially your own analyzer. You can build that. You can use open source traffic analyzers like Zeek and Suricata, or you could use several partners from AWS Marketplace. We have around 20 partners at this point who either will have very shortly or already have an appliance on your our AWS Marketplace, so that you can actually just use their solution right off the bat with a single click. Why did we build traffic mirroring? So traffic mirroring is one of the features that has been asked by our customers for quite some time. What we see is customers want to keep an eye on the traffic pattern that's actually coming in and out of your VPC. They want to keep an eye out on that unusual traffic pattern so that they can understand if there is an anomaly that's happening, or they want to do content inspection so that they can derive that if a particular instance or a workload in their infrastructure is compromised. Our customers also want to use traffic mirroring for troubleshooting and diagnostic purposes. A lot of time, our customers develop applications which they want to internally test before they roll out in production. And having live traffic between microservices or their applications within a VPC or across VPCs allow them to look at those blind spots or choke points so that they can take necessary action before either rolling out their applications in production environment or debug an issue in a production application. So what are the key benefits of VPC traffic mirroring? First thing is, up until now, our customers have been trying to mirror traffic using third-party agents. What they do is they install an agent in the user space of EC2 instance, and that agent then essentially copies the packet out of their EC2 instance. With traffic mirroring, you now have this native capability that you can turn on specific EC2 workload, so you don't have to install and manage third-party agents, which can be hard to manage and complex in terms of managing these agents, because if you have a lot of EC2 instance, it gets really tough to deploy and manage those instances or even upgrade those agents. The second key aspect is the security posture. When you run agents in user space, you're actually copying the traffic from the user space. And some of our security conscious customers don't want to accept traffic from user space, specifically if the workload is compromised, or they think if that workload is compromised. With traffic mirroring, what you're getting is you're getting packet captures right off of the network interface. And once this feature is enabled, you cannot disable or change anything regarding traffic mirroring from user space. So you can be assured that the traffic that you're monitoring is an untempered traffic right off of the ENI, very similar to a fiber tap in your data center, for example. And lastly, our customers have expressed interest in using multiple monitoring tools. And when you run an agent, you're kind of logged into a specific vendor. With traffic mirroring, you can choose to send a part of your traffic to a specific appliance and other part of the traffic to another appliance, so that you have wide variety of options for monitoring your traffic. So now let's take a look at what this traffic mirroring is made up of. There are three components of traffic mirroring. In order to successfully deploy and use traffic mirroring, you need to create targets. Targets are your monitoring appliances. You need to create filters to extract the traffic that you want to mirror. And then session is essentially the entity that binds your source and target. So let's take a look at each of this component in more detail. Let's go with target first. So target, as I mentioned, is a destination for your mirror traffic. As we speak, there are two possible targets that you can use. One is the ENI, or Elastic Network Interface, of an EC2 instance, or you could actually use Network Load Balancer as a target. You could have multiple sources pointing to a target. There are certain limits you need to be aware about. When you have Network Load Balancer as a target, you can have essentially unlimited number of sources pointing to a Network Load Balancer. If you have dedicated host, you can have up to 100 sources pointing to a single destination or traffic mirroring target. For other instance types, you have other instance types for target. You can point up to 10 sources to a destination. Very important aspect is make sure that on your target you allow VXLAN traffic to come in from sources. This is because when we mirror the traffic, we encapsulate the packet with VXLAN, making it a UDP packet. Another key thing I want to make sure is that when you choose your target, it is your responsibility to not overload the target by sending traffic more than what it is capable of processing. So because of this reason, we encourage you to use Network Load Balancer as a target so that you don't have to worry about high availability or the processing capacity of your monitoring appliance. Now let's talk about filters. Coming back to our example, you have the EC2 instance that you want to monitor, and you have a monitoring instance, for example. And let's say that you decide that you want to only mirror inbound packets coming to EC2 instance and not outbound. So you could actually just create a filter where you just say that I want to monitor all inbound packets and no outbound packet, and only inbound packets will be mirrored. So filtering comes in very handy when you have when you want to extract the traffic of interest. So before we get into filtering, let's take a look at the packet format of the mirror traffic. As I mentioned that we encapsulate the mirror traffic with VXLAN header. So here's how your packet would look like. You have an overlay IP address where your outer source IP will be the ENI IP address of the source, the ENI that you're monitoring. The destination address will be the ENI you want to send the traffic to. So in a if it's a standalone EC2 monitoring instance, it will be the IP address of the ENI. If it's a network load balancer, we will find out the IP address of the network load balancer within a zone and send the traffic to that network load balancer. For the UDP header, the key thing here is that the destination port is set at 4789, which is the VXLAN port. And then you have a VXLAN header where you can specify VXLAN ID or VXLAN network ID, and you have up to 16 million options that you can choose from. If you don't specify a VXLAN ID, we will randomly choose one of the value between 0 to 16 million and assign that to a packet. A key thing to note here is that when you're mirroring traffic from a lot of instance, a lot of VPC, and sending it to a central destination, choosing a VXLAN ID for different session, a unique VXLAN ID for different session will allow you to distinguish the packet on the receiving end. So there are some cool logics you can build by making sure that you choose the unique VXLAN ID when you create a session. Another thing, since we are encapsulating the packet with VXLAN header, any packet, if your target MTU or the MTU at the target instance is set at 9,000, we will truncate packet if they are over 8,946 bytes to accommodate the headers. So make sure that either you set your MTU lower than 9,000 on the source, or if you are okay with receiving the truncated packet on the destination. Now, traffic mirroring filter. The filter that you create with traffic mirroring is very similar to a network ACL with a couple more options. Those options are flow direction and truncation. So let's do an exercise. Let's create a traffic mirroring filter for filtering only HTTP traffic on port 80. So let's say that I want to mirror all the traffic which is coming into my ENI. And so I select the flow direction as ingress. Then I want to monitor obviously an HTTP traffic. So I will choose protocol TCP. The source IP of the packet can be anything. So it can come from any source. It can come from any source port as well. The destination IP address would be my IP address of my server where I want to monitor the traffic. And the destination port will be port 80. Now, this is as simple as it gets to actually create a filter. Another option that you can specify with traffic mirroring session is that you can choose to create a truncation so that you can just mirror, let's say, first 200 bytes or first 1,000 bytes of the packet. In this case, I choose to copy the entire packet. So I don't, essentially, I skip that truncation field and I get the full packet that's coming in and into my ENI. And that's how you create a filter, right? Now, let's take a look at this session. So session is the entity that binds the source in the target with the filter rules so that you only mirror traffic that you want to mirror on your source. So as mentioned, traffic mirroring session or traffic mirror session has three components: a source, target, and the filter. There are many other attributes when you create a traffic mirroring session. We'll go into that when we do a quick demo. A key thing to keep in mind is that you can have up to 3 sessions on a source. Now, this comes in handy when you want to send a part of traffic to one tool and other part of the traffic to another tool. So we have a concept of session number. So you can have, when you create traffic mirroring session, you can specify session number for a particular source ENI, and the lower session number is the highest priority session. So for example, let's say that you want to monitor all your HTTP traffic using, let's say, an appliance 1, and then rest of the traffic you want to monitor with appliance 2. So in this case, what you would do is you will create a session with, let's say, number 1, and in that session 1 you will capture all your HTTP traffic and send it to appliance 1. And then in session 2, which is a lower priority session than the session 1, you will capture all the traffic and send it to appliance 2 here. The idea here is that we mirror packet only once, but with the right session IDs, you can choose to mirror a part of the packet, a subset of the traffic, and send it to a tool 1, and another subset of traffic and send it to another tool. Now let's take a look at some of the more advanced topics on traffic mirroring. But before we get there, let me clear this out, the key differences between flow logs and traffic mirroring. And you can obviously use flow logs and traffic mirroring together. With flow logs, you actually get the logs of the network flow. You do not get the packet captures. With traffic mirroring, you get the real network packet with the ability to truncate those packets. The destination for flow logs can be Amazon S3 or CloudWatch. For the destination for traffic mirroring as of now can be ENI or NLB. With flow logs, you essentially get the phi tuple of the network traffic, so it's a metadata, and with traffic mirroring, it's a real network packet, including the payload. So a few things to keep in mind. The very important part is the performance of your EC2 instance. Traffic mirroring or the mirror traffic is counted towards your instance bandwidth. So it is very important that you understand that when you try to enable traffic mirroring or your EC2 instance, you're going to generate more traffic. So in this case, let's say that you have a 1 Gbps traffic coming inbound and a 1 Gbps coming traffic outbound. And if you choose to mirror traffic, all the traffic, such that you're not doing any filtering, then you will have 2 gigabits of mirror traffic, which means that there will be a total 4 Gbps of traffic on this instance as opposed to just 2 Gbps, because you are mirroring that traffic which is coming in and out of your ENI. So make sure that you right size your EC2 instance. If an instance is important to you and it's running hot, then you might want to consider up-leveling the family of that instance so that you have enough capacity and enough bandwidth available on your source. Similarly, on the monitoring instance side, you need to be aware that you're not sending and overloading your target by sending mirror traffic more than what the capacity of the monitoring instance is. So, so this is an important thing that you need to consider before using traffic mirroring. As I mentioned, right sizing your source and target is a very important consideration when you're using this feature. Another thing, we prioritize production traffic in event of congestion. So if there is a congestion on your ENI of the EC2 instance or source EC2 instance, we will prioritize production traffic over mirror traffic, which means that if you are running at a pretty much at your capacity, you might see that the mirror traffic might get dropped because we want to prioritize production traffic on that ENI. Now, let's talk about how do you scale your monitoring appliances so that you can actually mirror traffic without worrying about right sizing your target. So, as I mentioned, traffic mirroring is supported with network load balancer. So with network load balancer, what happens is that you specify your NLB as a target. And once you specify NLB as a target, the traffic coming in and out of your EC2 instance can actually be sent to a network load balancer. So in this slide, you have an EC2 instance that you want to monitor, the bigger picture here, where you have traffic mirroring enabled, and you have traffic coming from internet gateway, as well as you have traffic coming from another EC2 instance. All of that can be sent to a network load balancer, and you don't have to worry about the capacity on the destination side. Obviously, you need to run your monitoring instance in the auto scaling group so that it can automatically scale up and down when your mirror traffic increases or decreases. Now, a bit about the flow hashing. So, a key thing to keep in mind is that you need to run UDP listener on port 4789, which is the VXLAN port, on network load balancer to make sure that your traffic mirroring works with network load balancer. Now, traffic mirroring, as I said, is UDP only. The way we hash traffic on network load balancer is that we look at these 5 things: source IP address, source port address, destination IP, destination port, and protocol. So a UDP flow will have the same source and destination, so it will consistently be routed to a single target. Different UDP flow will have different source port, so they can be routed to different targets. So it's an important thing to consider, and every flow, a single flow will consistently land on a single target, so that you don't have to synchronize the state behind the load balancer. Now, some of the deployment options. There are a lot of deployment options that are possible with traffic mirroring. You could actually have a decentralized model where you have a centralized InfoSec VPC, where you want to monitor all your mirror traffic coming in from, say, hundreds of your VPC. So you could choose the connectivity option of VPC peering. Obviously, you have to keep in mind that your routing is configured properly, so that your mirror traffic can be routed correctly over peering. You could also use transit gateway instead of peering, and if your route tables are configured properly, the mirror traffic will be routed to the centralized InfoSec VPC over transit gateway. You could have your source and target into 2 different AWS accounts if you want to. So cross-sharing of target is supported. So you could have source in account 1 and destination is account 2. That's totally possible as well. Now, let's take a quick look at how to configure traffic mirroring. So this is a quick walkthrough of how do you create a mirror session. So traffic mirroring is a VPC feature. So you should go to your VPC service console. Once you go there, you would see at the bottom you have a traffic mirroring section. There are 3 parts here: traffic mirror session, mirror target, and mirror filter, as we discussed. So in order to create traffic mirroring, you start off by creating mirror session first. By default, as I mentioned before, there are no mirror sessions, so you need to create one mirror session to start traffic mirroring on a source. When you create a mirror session, you get following options. You can actually specify a name and description. These are optional fields, but we highly recommend giving right tags and the description so that it's easy for you to recognize what this mirror session is doing. So I'm giving a name tag, I'm giving a description to this session. Then I come and select the source. The source can be any ENI in your VPC. So here I choose one of the ENIs, and then I specify a target. In this case, I've created a target. So I go and select the traffic mirroring target, and this is the ENI on the monitoring appliance that you will receive the mirror traffic to. There are other attributes that we had discussed. Session number, where the lower number is the highest priority session that will be evaluated. So you can specify that. You can specify VXLAN ID. You can specify packet length if you want to truncate the packet. And then obviously you need to specify the filters. So I'm going through each of these fields now, and I've already covered what these fields are. And then the key important part is making sure that you specify a filter. If you don't specify a filter, there won't be any packets that will be mirrored. So filter is an essential part of the traffic mirroring session. So in this case, I'm creating a filter which monitors TCP traffic on port 8080 on the source interface that I just selected. And that's it. Just you hit create, and that's your traffic mirroring session. With each traffic mirroring session is a separate resource, so it will have its own resource ID. That's how you create a traffic mirroring session. So now you have created a traffic mirroring session, but what do you do with these packets, right? So there are many things you could do. One is you could choose one of our APN partners. As I mentioned, there are several APN partners that have integrated with AWS traffic mirroring or VPC traffic mirroring, so that you can use their solution to monitor and analyze traffic in your VPC. Just to give you an idea, there are around 20 partners that we have, and the list is growing. Folks like ExtraHop, Gigamon, Palo Alto, you can use their solution and get the plans from AWS Marketplace. And as this will continue to grow. We are working very closely with these partners, and there's a lot of capabilities that you can actually use from their appliances to actually keep your network safe. Another thing that you can do is you can build your own analyzer. We have some code written here that you are more than welcome to capture the screen and leverage that code. Here, let's say that you want to monitor your HTTP request coming to a web server. So you can actually easily capture the HTTP request coming in and out of your EC2 instance and analyze that traffic. So let's take a quick look at how we have built the analyzer, right? We have so these are just PowerPoint animations, but this is a real code that you can actually leverage. So we have imported some packet libraries to provide decoding of the packets in Go language. We've imported layers, which provides the decoding layers for many common protocol, and then PCAP library to allow you to read PCAPs of an ENI. So once you do that, we have written a small code that starts a PCAP capture on the Elasticast or Elastic Network Interface on the EC2 instance, and then we go and grab the VXLAN packet, which is how your mirror traffic is encapsulated, and you read it off the mirror source. So what kind of output you get? You see some kind of a packet captures on, when you enable this script on the target or mirroring target, you get some kind of packets like this. But what do you do with this packet, right? So let's, you can use this code to grab the HTTP request from the application payload, and this is how your output would look like. So I have a mirror destination where I have this script running. I have this is the source where I have the server running, and where I'm going to monitor traffic on port 8080. And then I have a client trying to use this web server. As the client starts trying to reach this web server, a simple hello world application that we've written, you would see the HTTP packets coming on the mirror destination that you can use to monitor your traffic or do a bunch of things to make sure that your environment is safe and secure. Now, what can you do once you have captured the traffic? There are a bunch of things that our customers are trying to do. You can send the mirrored packet to S3 for archival and record keeping purposes. You can send it to Amazon Kinesis, or you could actually generate alerts on Amazon CloudWatch if you find something suspicious. So this was covering APN partners, and if you want to build your own analyzer, you can actually also use open source tools which are readily available and already support traffic mirroring. So we have a whole documentation page on our website where you can find documentation on how to use use open source tools like Zeek and Suricata to monitor your traffic. A lot of our large customers are already using these open source tools. So you can, there's a lot of capabilities that are available here, which you can use to, analyze traffic using these tools. So here's a link to get you more information on these open source tools. So what are any other consideration with traffic mirroring? There are a few things that I want to make sure that you're aware about. One is that the mirror traffic on your EC2 instance is not subject to egress security group. This is because if you really want to monitor traffic, you can, the administrator can enable traffic mirroring on EC2 instance, and that means that the developers or user of EC2 instance cannot disable mirror traffic by just creating an egress security group. So, your egress security groups are bypassed for mirror traffic. Flow logs also do not capture mirror traffic. So again, if to secretly monitor traffic, these things come in handy. key thing again, the packets that will be mirrored are the only packets that are allowed by security groups and ACL on the EC2 instance. So how are our customers using traffic mirroring, right? Traffic mirroring actually is creating many new opportunities for our customers. Our customers have been using traffic mirroring. We have just launched this feature, but in the short span of time, what we are seeing is customers are using traffic mirroring to continuously monitor their sensitive workloads. They are, in many cases, when you have an acquisition or you're merging some part of your, other business units or other networking components or other infrastructure into your environment, traffic mirroring becomes a quick and easy way to figure out what kind of traffic is actually going through those workloads as opposed to what is being told to you, right? And then another thing that our customers are using this is for incident response. So when you have an alert coming from, say, guard duty, or you have some analyzer using flow logs, you can now go and look at the actual packets by enabling traffic mirroring as an incident response, right? So the key thing here is having an automation here, right? So one example where one of our customers is using this, you have a guard duty, you have some traffic coming in and out of the EC2 instance, and the green traffic is essentially your good traffic, but between that green traffic, you have some bad traffic coming in, and guard duty comes in and it alerts the fire, and those alerts are shown, show up on CloudWatch instance. Now, our customers have automated this environment where your CloudWatch events will trigger Lambda event, and Lambda will actually match the alert and figure out what ENI it needs to monitor. It'll create a monitoring instance on the fly with either an open source tool or using one of the APN partner solution, and then it'll enable traffic mirroring on the EC2 instance. Once traffic mirroring is enabled, you would be able to see the actual traffic coming in and out of that EC2 instance, so that you can monitor that bad traffic. And then you could use, in our case, one of the customers have been using Zeek and Suricata, where they're monitoring the traffic. They are actually creating the flows from the monitoring instance and sending it to S3 bucket. And then, you can use Amazon Athena for to provide a human readable format of these logs to humans who can take high judgment calls, right? So this is just one framework that our customers are using in production today. Once you are done with monitoring your appliance EC2 instance, you can then have Lambda disable the traffic mirroring, terminate it, and then you can terminate the monitoring instance as well. So the cleanup can happen automatically as well. Another thing is for incident response. So same example, but human is initiating an API request to monitor an instance because it found some suspicious traffic or something that they want to monitor. So the entire workflow remains same. Instead of guard duty, and human is initiating this request, right? So pretty similar stuff. And lastly, this is the build-up slide where everything remains exactly the same as the last slide. It's just that the initiation of the request is coming from an incident responder as opposed to guard duty. And then the last thing is you could actually do things like at the start of the instance itself, Lambda can read the CloudTrail event and figure out what ENIs have been created in your environment and automatically enable traffic mirroring for your sensitive workload so that you can monitor the traffic, and then if you have the logs generated of the monitoring instance, you can send it out to S3 and then use Athena to inspect those logs. Key difference here is that you can, if you're monitoring a sensitive workload all the time, we recommend using network load balancer as a target, so you don't have to worry about it, about your high availability and scale. So all of these frameworks with automation is possible, and they're opening up new opportunities for our customers to keep an eye out on the network traffic in your VPC. And that's all I had. So if you have any questions, here is my email address. I'd be happy to hear feedback, concern, or anything that you feel you want to know more, or you want to see this feature to be enhanced to include some of the things that you want to have with traffic mirroring. Thank you so much.